Hello students, welcome back. So we are learning linked list. In the previous session, we had already seen the introduction to linked list. What are the nodes? What are the various part of a node? And also we had seen the different types of linked lists. And we had seen briefly what are the various operations which we can perform on linked lists. So today we are going to learn the very first operation, which is nothing but creating a linked list. Okay. So before going directly into creating, once again, let us see what are the various operations which we can perform. The first one is creating a linked list. Then we can traverse the linked list. Traverse is nothing but visiting each node of the linked list. Then we can insert an item into a linked list, deleting an item, searching an item, and we can also merge two or more linked lists. Okay. So first one, let us see how can we create a linked list. So in linked list, we start with a node and create nodes and link to the starting node in order and sequentially, isn't it? So we all know that how does a linked list start? First, we have something called as a start node or a head node, which contains the link to the very first node, isn't it? From here, then linking starts. This one will be linked to the first node. So that is what it's saying. We start with a node and create nodes and link to the starting node in order and sequentially. That means we are going to go on creating the nodes and we are going to link them, okay, one by one. And then the pointer start contains the location of the first node, isn't it? So this always contains the address of the first node. This is my first node and this is the one which contains the address of the first node. Next, the pointer field of the last node must be assigned null. Which one is that? Always the last node has to have a value null in its pointer field. Now elements can be inserted anywhere in the linked list and any node can be deleted. Now that is the beauty of a linked list. Wherein which in array, if you remember, if at all I have to insert an element over here, all I need to do was shift them one by one and then create a space and then add. Similarly, if I have to delete a data item, if at all I'm deleting this, once I delete that, I had to shift the values, isn't it? So in this case, that is in the case of linked list, this is not at all required. Anywhere we can add. If at all I want to add, I can simply remove this link and add that link to the new node and link it something like this. I can do it in the beginning, I can do it at the end, I can do it in the middle, anywhere I want. So that is what the advantage of the linked list over the array. So that's what it is saying. Elements can be inserted anywhere in the linked list and any node can be deleted, right? So see here, how do we declare a linked list? Now I hope you all know what does the meaning of a structure. This we had learned in the first year, first PUC. Structure is something where we group different type of data types. Now what is the meaning of that? For example, if I have to say I'm declaring int I, okay, j, then I'm declaring a float, I'm saying marks, okay, then I'm saying character and I'm saying name. Suppose these are all the details of a student. Now every time I have to create a name or enter a details of a student, I have to keep creating the data types, isn't it? So instead of that, I can directly create a structure of name student and I can include all these details in here. So I can say int I comma j, I can say float marks, okay, then I can say character name. So once I do this, what happens is this will create a structure. Now this entire thing becomes one. So I have grouped the various types of data. Now these data types can be of similar type. These data types can be of various different types. So once I group that, all I need to do is keep declaring the object for this. Okay, so I'll say student S1. So whenever I say that this S1 will have all these details. So I can have S1 dot I can have S1 dot name, isn't it? So something like this. So structure is nothing but it is helps us to group together the various types of data types, right? So now see here I have a structure node. So before that, the nodes of a linked list can be created by the following structure declaration. So how do we do that? So this is a standard declaration for a linked list for your syllabus. Okay, so this is how we are going to declare a structure for a node. So whenever I say this, declare something like a node is going to get created. So what do we have in this node? We have a data, isn't it? So how is that data? Data here we are considering saying that it is of type int. Okay, so I am declaring a data type of type int inside this structure. Again, I'm going to have a link to the next one. Now here link is nothing but here we are going to use a pointer variable. Now this particular pointer variable we are going to learn in detail. So as of now you understand that pointer variable is a data type which always holds the address of another variable. It is a variable which always holds the address, okay, and it is always declared something like this, where we are going to declare data type star the variable name. So when I say this, whenever I see this star and a data variable, I know that p1 is a data p1 is a pointer variable and it is going to hold the address of this data type. Okay, so here what I'm going to do is I'm going to declare a variable called as link, pointer variable called as link of type node. So what is this node? This node is nothing but this structure again. So this is a pointer variable which is going to hold the address of a node type of variable, right? So this is my link part. Okay, so if I have a node, this is nothing but my link part and this data is nothing but my data part. So this is how we are going to declare the structure for the creation of a node of a linked list. So once I declare this structure, how am I going to create or declare the node? See, this is the way. I'm going to write the name of the structure and then I'm going to say star node 1, star node 2. This is nothing but this is going to create a node 1 here and this is going to create a node 2 here. So remember this, okay? Similarly, instead of this, I can also say that instead of writing it something like this, once I close the bracket, directly I can say star node 1 and star node 2. In this case also, we are going to create a node 1 and node 2, okay? So you need to remember this structure declaration of a node. So this is our keyword, okay? This is a keyword, is going to remain same, this is not going to change. This can be of your choice. We are giving it as node for the better understanding because we are using this structure to create a node, isn't it? So this is the keyword, this is a node, and inside that I am declaring two type of variable because in a node we need a data and a link. So for data I'm going to say int data, and for the link I am saying that it is going to get linked to a node type of a variable, isn't it? Because this is another node. That's why I am declaring this link as a variable, pointer variable, which is going to hold the address of another node. That's why it is also of type node. I hope this is clear. And this node 1 and node 2 is nothing but I am declaring the node 1 and node 2 of this type. Okay, so this is nothing but creating two nodes. So this is all about declaring a node. Next, see the explanation for the same. The data is the information field and link is the link field, which we have seen many times, isn't it? The link field contains a pointer variable that refers the same node structure. Okay, such a reference is called as a self-addressing pointer. Why? Because it is going to point to another node. Okay, so this is nothing but a self-addressing pointer. The above declaration creates two variable structures, which are those which are node 1 and node 2. Okay, so these are the variable structure variables. Okay, so each structure will be taken as a node. Thus it is linked list that contains two nodes. So in the previous declaration we have created a linked list with two nodes, node 1 and node 2. Another node cannot be inserted if it not already declared. So every time we have to declare of type node. Okay, so we have to say node star some name, only then a node gets created. Also, there may be cases where the memory needs of a program can only be determined during the runtime. On these cases, program need to dynamically allocate memory, for which C++ language use the operator new and delete. Now, what is the meaning of this? Now, in this case, the previous slide, whatever we see, the declaring of node 1 and node 2, here we are declaring them statically, as in we are declaring saying we want two nodes. In certain programs, we might want to create the node dynamically when the program is running. Okay, so in such cases, we are going to use the new and delete operators. Using them, we are going to allocate the memory. So let us see little bit briefly about what is this new and delete is all about. Okay, so now operator new allocates space. Always remember that this particular operator, it allocates space, and whenever I say a square bracket open close, it allocates memory space for the array. Arrays, you might be knowing, we always declare it something like this, isn't it? When I say this is nothing but A is an array, or it means we are allocating a consecutive memory location in the memory, and this is of type int, isn't it? So similarly, when I say new open bracket close bracket, it is going to allocate memory space for an entire array. Similarly, operate delete deallocates the storage space. Now this deallocation happens only for those space which have been allocated using new. Okay. Similarly, delete of open bracket close bracket deallocates the memory space which has been allocated using this particular operator. So there are these 4 types. Okay, I hope this is clear. Now see this, what is this new operator? How does it work? This is a dynamic memory is allocated using the operator new. Dynamically is nothing but when the program is running, it is going to allocate memory, not like how we declare initially. It is not static. Okay, it is dynamic memory allocation. New is followed by a data type specifier, and if a sequence of more than one element is required, the number of these within the bracket. So we are going to mention it inside the bracket. Suppose if I want 5, I'm going to say 5. If I want more than 1, if I want only 1, then I'm going to just say new. If at all I want more than 1, then I'm going to write a open bracket, close bracket, and if at all I know the number, I'm going to mention the number. So it returns a pointer to the beginning of a new block of memory allocated. This is important. What does it return? It returns a pointer to the beginning of a new block of memory. Right. Now, how do we write it? So we are going to have a pointer. Why? Why pointer? Because pointer always holds the address, isn't it? And what is a new, when I say new type, what does it return? It returns the address, isn't it? So address is always stored in a pointer variable. That's why we are saying pointer is equal to new, and we are going to mention the type. Okay. And another way is pointer is equal to new type with the number of elements. So this is for array. Okay. And this is for single variable. So see this example here. I am declaring a pointer variable first. I am saying int star temporary. So temporary is a pointer variable of type int. And in this temporary, I am going to store new int of 5. Okay. So this is going to create a memory allocation of 5. And whatever the beginning address is there is going to get stored here in the temporary or the TMP variable. I hope this is clear about the new operator. Next, let us see what is a delete operator. The memory allocated dynamically is only needed during a specific period of time within a program. Obviously, because it gets allocated during the runtime of a program, isn't it? Once it is no longer needed, when do we don't need it? Once we come out of the program, we don't need it, isn't it? It can be freed so that the memory becomes available again for the other requests of dynamic memory. So for this purpose, operator delete is used. In delete also we are going to first delete a pointer. So the whatever the pointer is there, which we declared before, we are going to write that pointer and we are going to just say delete pointer. Similarly, for the array, we are going to say something like this. So when we say that, whatever the memory has been allocated over here is going to get released, right? The value passed as an argument to delete shall be either a pointer to a memory block previously allocated with new or a null pointer. In the case of null pointer, delete produces no effect. Okay. So this pointer is nothing but which holds the address of a memory block which has been declared using the new operator. Okay. So that is all about new and delete. So new we are going to use to create a memory dynamically, and delete we are going to use to remove or release those memory which has been allocated, right? So dynamically the memory space is allocated for the linked list using the new operator as follows. So how do we allocate the memory for our linked list? Because we are learning about linked list right now. So first we are going to declare a pointer variable of type node, okay? Because we have a node structure, isn't it? And in that structure, whatever we have, we want our even the address to be of that type. So that is why we are declaring a pointer of type node. Now I am going to say P is equal to new node. Now what is this P? Now P is where our new node address is going to get stored, right? Now I'm going to say, so once I declare that, okay, now P will have two parts, data and link part. Now what is the data part is going to hold? Whatever the number we want to store. Okay, so suppose this number, suppose this num has 5 stored, then 5 is going to get stored here. And link of P, what is that? This is my P, this entire thing is my P. So link of P is going to become null. So by doing this, I have created a node. I hope this is clear. So when I say P is equal to new node, P is going to hold the address of that node. When I say data of P, it is nothing but this. When I say link of P, which is nothing but the link part of P. Okay, so this is how we are going to use the new operator in order to create a linked list nodes. Now, the very first program of this data structure is how to create a linked list and appending the nodes into the linked list. This is a quite huge program, students. So I have how I have done this slides is, in the first one I have written the class declaration and also the public declaration. In next coming slides I have written the every function of it. Okay, so let us go through that one by one. At the end, when the main comes, I'm going to explain exactly how it works. Okay, so concentrate with me. The first one is we are going to declare a class, and the name of that class is going to be linked list. Okay, so in the private part of this class, I am declaring my structure. Okay, so this structure declaration we have declared already, we have seen already. The name of that I'm going to say node, and it has two parts. The first part is the data part, which is nothing but int data, and the second part is nothing but the pointer part, where I'm going to have a pointer variable by name link, which is of the type node. Okay, now see here, first I have created a single node whose name is start, which is nothing but my head pointer, isn't it? Now this is going to store the value of the very first node. So that's why the start we are going to declare it along with the structure declaration, mainly because whether our linked list has nodes or not, we have to have a start node or a head node. Okay, so this is the first part. Next, in the public section, we are going to declare a linked list. Now, you might notice that the name of this function as well as the class is same. Now, this is called as a constructor. Okay, constructor we are going to learn in the coming session when we start C++. Now, what is this constructor? What is the purpose of a constructor? Is nothing but it is used to do certain initialization. Okay, and the beauty of the constructor is, as soon as you create an object, how do we create an object? In the main function, when I say linked list, linked list. Okay, in this case, my name of the class is linked list. And if whenever I create an object, suppose I said L1. So what is this? This is nothing but an object of type this class, isn't it? So whenever I create an object, automatically it is going to invoke my constructor. I don't have to call this function. So that is the beauty of the constructor. Constructor gets invoked automatically as soon as the object is created of that particular class. Okay, always the name of the class and the name of the constructor are going to be the same. Okay, so this is my constructor. Void print. So this function I'm going to use to print the contents of the linked list. Void append. Here I'm going to add new node at the end of the linked list. This is the append. Okay, so remember I'm going to add a, suppose this is my start, I have a node something like this. Then if at all I am calling this function, it is going to add at the end. It is going to add a new node at the end. Okay, so here I am passing number as a parameter. So what it could be, this number is nothing but the data. Okay, so data value I am passing as a parameter for this particular function. Next, void count. So counts the number of nodes in the linked list. So this particular function is going to count the number of functions. So I hope this definition of the class is clear to you all, right? So now let's go ahead and see the functions one by one. So the first one is a constructor linked list. Like I said, the constructors are used to initialize the values. So here, I hope you remember that we have already declared along with the structure definition the start node. Okay, so start node in this particular constructor, I'm going to say that this is nothing but null. So this I'm going to declare it as null. So as soon as I'm creating a class object, what is going to happen? The linked list will initialize, the constructor will initialize the start node to null. Okay, so that's all it does, this particular constructor. Next function is linked list print. Now here we are going to print the linked list. So how are we going to start? So first I'm checking if the start is equals to null. Okay, so if my start is null, then I'm going to say linked list is empty. Clear? Otherwise, what I'm going to do is I'm going to traverse the linked list. That is, I am going to visit each and every node. For example, let me take, this is my start. Okay, this has 100 as a value. This is my 100. This has 1. This has 200. This is 200. This is null. Okay, this is an example I'm taking. This is 2. Suppose this is my linked list. Now what is going to happen then? Then I'm going to say cout linked list contains. Then I am declaring a pointer variable here, which is of type node. I'm saying P is of type node and it is equal to start. So I'm going to say that this is P. Okay, initially. Now I'm saying while loop. So what I'm doing here, while P is not equal to null. Is P is not equal, is P is equal to null in this case? No, P is equal to 100 in this case. So what is going to happen? While P is not equal to null is going to become true, then I'm going to come inside the while loop. I'm going to say cout P data, as in print out the data of this. Okay, so P is equal to 100 is nothing but I'm going to come to this one. So what is the data of this one? 1 is going to get printed. Next, I am saying P is equal to P link. So what is the meaning of that? I'm going to say this was 100 initially. Now I'm going to say P is going to become whatever is there in P link. So this is going to become 200. Okay. So again, I'm going to come back. I'm going to say is P, while P is not equal to null, is P null? No, it is not null. Again, this is going to become true. Now I'm going to say cout P data. So what is 200? 200's data is 2. So 2 is going to get printed. Again, I'm saying P is equal to P link. So P link is what? Null. So this is going to become null, right? So now this is null. I'm going to come back again. I'm going to say P is not equal to null. But is it not equal to null? It is equal to null, isn't it? So this is going to become false. We are going to come out. So we have printed the contents of our linked list. Okay. So in this particular function, very first thing is we are going to check if we are going to declare sorry, we are going to check if the start is equal to null. If it is null, directly we are going to say that the linked list is empty. Otherwise, we are going to create a node of P, and I'm going to say it is equal to start, and I'm going to traverse each node, and I'm going to print the content of that node, right? So we have seen two functions here. Next function, what you're going to see is append. Okay, this is nothing but we are going to add a node at the end. Suppose, let us take the same example. This is my start. Okay, and this has 100. This is my 100. This is my 200. I have 200 here. This is 1. This is my 2, and this was null. Right. Now let us go through this. Now I'm saying star new node. I'm creating a new pointer variable here of type node. Okay. Now I'm saying new node is equal to new node. Now see the difference between this. This is the name. Okay. New node name. And when I say this is a new operator, which is nothing but we are allocating a memory to this. Okay. Of a new type. Now I'm going to say new node data is equal to number. From where did I get this number? This number is nothing but a parameter which I passed. So what I'm doing here exactly, first I am creating a pointer variable, okay, which is of type node. Then I'm allocating the memory. So that is what is going to be done with these two lines, okay. So this two lines has created a node now. Now I'm saying this new node data. So how do I access the structure elements? Using this pointer. Okay, so when I say new node data is nothing but this. So whatever the number I have passed, suppose I have passed 3 here, is going to get stored here, and I'm going to say new node link is equal to null. So I'm just creating a node something like this. Next, how am I going to link it to this? So let us see that. Once I created the node, okay students, so see here carefully, these first 4 lines is nothing but here is where we are creating a node. These 4 lines are used to create this particular node. Next, I'm going to check if start is equal to null. In case there is a start and it is null, means there are no nodes in this. Then what I'm going to do? Create the first node. Then I'm directly going to say start is equal to this node. When I say that, directly this is going to get linked. Okay, and this is going to become the first node. So, and I'm saying is inserted as a first node. Otherwise, in our case, what happened in our case? This is our example, isn't it? In that case, what is going to happen? So, else part, we are going to come to the else part because here my start is not null, right? So, I'm going to create a node again like before. I'm going to say node star P, a pointer I'm going to create, and I'm going to say it is equal to start. So, P is going to come over here. While P link is not equal to null. What is a P link? So this is 100. So link of the 100 is nothing but this part. While it is until it becomes not equal to null, I'm going to continue this. I'm going to say P is equal to P link. So first I'm going to see what is the link. Is this null? It is not null. Then P is going to become 200, whatever the value is there. Then the P value is going to come over here. Next, again, I'm going to check the link. Link is null. So since this is null, we have reached the end. While P link is not equal to null, in this case, it is null. So this is going to become false. So once it is false, what is going to happen? I'm going to add. So basically what we are doing is we are creating a node P in order to traverse each node until I reach the last node. So when I get null, this is nothing but this is my last node, isn't it? So once I get my last node, what am I going to do? I'm going to say that P link is equal to new node. So here in this link, I'm going to say the address of the new node. Suppose 400 is the address. I'm saying P link is equal to new node is nothing but the address of the new node. Since my P is here, the link of that particular node is the address of the new node, right? Now I'm saying it is inserted. So when I say 400, automatically this is going to get linked. I hope this is clear to you all. So what did we do? Initially, we created a new node using these 4 codes. Then I added the data value here. Then I said the link is equal to null. So once my node is ready, what I'm going to do? I'm going to go to the my linked list and start looking for the last node. I'm going to traverse it and look for the last node. Once I find the last node, I'm going to remove the null and add my new node address. And by doing that, I'm going to add my new node. Okay, in case my start was empty, as in my linked list was empty, directly I'm going to link it to the new node by using these codes, right? I hope this is clear. So the next function is to count. Okay, so here we are counting the number of nodes present in the linked list. How can we do that? It is very simple. I'm starting node start p. Okay, so let us take an example. This is my start. Okay, let me now, since we have appended, let me take it as 4 nodes. So this is my 100, 200, 400, 1, 2, 3, 200, 400. This is null, right? Let us count now. I'm saying node star p. So it is going to create a pointer variable, and also I'm declaring c is equals to 0. Okay. Now for p is equal to start, for my p is over here, so it has a value 100, so it is going to be here. If p is not equal to null, p is equal to p link. I'm going to go till my p value is not null. Okay. So what is the p value right now? It is in 100, isn't it? Which is over here. Now C++. Now since it is 100, I'm going to increment it to 1. Okay. Then what I'm doing? P is equal to p link. So p link is nothing but 200. So p is going to become 200. That means p is over here now. Now again, I am going to increment the, is p is not equal to null? Is it null? No, it is not null. We have 400. So I'm going to increment c to 2. Then p is equal to p pointer variable. That means p is equal to p link. So what is a p link? P link is 400. So p is going to become 400. So p is over here now. So again, I'm checking p not equal to null. Isn't it? Is it null? P is not equal to null. It has a value 400. So I'm going to increase C to 3. And then I'm going to say P is equal to P link. So which is P link? P is going to become null now. Okay. Again, I'm going to check P is not equal to null, which is false. Hence, I'm not going to increment my C, and I'm going to come out. And I'm going to come out and say number of elements in the linked list is C, which is nothing but 3, which is correct, isn't it? How many nodes do I have? I have 3 nodes. Right? So this is how we are going to count. We are going to start with P. I'm going to initialize it to start, and I'm going to go to each node until my P value becomes null. And I'm going to go on increment a counter, which is going to count the number of nodes. So this is about my count function. So we have seen all the function, how it executes with the example. Now let us come to our main function. Okay. So in the main function, what am I going to do is I'm going to create an object which is of type linked list. Okay. So this object is a pointer variable to the linked list class, and I'm going to create a memory for this, which is of type linked list. So what is this linked list function? This is nothing but we are going to invoke our constructor. Okay, where I'm going to initialize start to null. I hope you remember that. Okay. Now, first I'm going to say object print. I'm going to call the print function. Then, so initially what is going to happen? The start is going to become null. Then I'm saying print. So when I print, what is it going to come as? It is going to come as null, isn't it? There are no values. Then I'm saying append. So when I say append, I'm going to create a start, and I am adding a data 100. Now when I print, how am I going to get? I am going to get 100 as a value. Now when I count, what is going to be the output? I am going to get 1 node, right? Now I am appending 200, as in I am adding 200 over here. Now when I print, I am going to get 100 and 200 as a value, and the count is going to, I am going to get 2, isn't it? Because I have 2 nodes. Next, I am appending 300, which means I am adding another node over here, 300, and I am printing here. So I am going to get 100, 200, and 300. Next, I am saying count. So when I count, I am going to get 3 as a value. Okay, so these output I have written just like that. I have not mentioned the statements, whatever they have mentioned. Okay, but I hope this is clear. So I'm creating an object here. So as soon as I'm creating an object, this constructor gets called where I'm going to initialize my start to null. So when I am say print, it is going to print the value of the nodes. When I say append, it is going to go on add the nodes. Okay, I hope this is clear. So I'm adding 100, I'm adding 200, I'm adding 300. As soon as I'm adding, I'm printing the node values and also I'm counting the values. So initially it is going to be 101, then it is going to be 100, 202, then it is going to be 100, 200, 303. The count is going to be 3 nodes, right? This is a quite big program and it is very important for you to understand this. I hope this is clear to you all, right? So see the output here. This is just exactly how the statements are. First, it is going to be linked list is empty. When we print, initially it is going to be empty. Then we are appending 100. So the statement it is going to be 100 is inserted as a first node. Then we say, so this is when we say append, when we call the append function, right? So this is when we call the print function, and this is when we call the count function. This is again when we call the append function. Okay, this is when we call the print function. It is going to print 100 and 200. This is when we call the count function. This is again append. Okay, you can go back and check the entire program together. It is available in the textbook. The same thing I've explained here. This is the print and this is our count function. So this is how the output is going to be. Okay, I hope this is clear, students, and I also hope that it is helping you in your preparation. So that's all in this today's session. In the coming session, we are going to learn more functions on the or the operations on the linked list, right? Keep learning. Thank you for watching. Take care.